So when we are talking about scattering, first we will discuss classical scattering, little bit of classical scattering, because unless until you will not understand the formulation of classical scattering, you cannot understand the formulation of quantum mechanical scattering. So this is very important. So what is differential scattering cross section, why we are calculating it, how we are calculating it, these all things are very important. So today's class is all about the classical scattering. We will try to solve one or two problem also onto this basis. And then tomorrow we will go for quantum mechanical scattering. First, we will go for Born approximation, because most of the question is coming from Born approximation. And then we will also go for what? Partial wave analysis and phase shift method to understand the theory of scattering. So let's try to go for that and have a patience, because the topic is a little bit conceptual, mathematical, huge mathematics can we come into picture. But what you have to do, you have to be little bit patient. आपको रखना होगा, patience रखना होगा, है ना? चलो. So let's see what we are going to do. In general, in our case, we are talking about the spherical symmetric potential. What is meaning of a spherical symmetric potential? The potential is only function of r, and that is independent of theta. Means if you are changing the theta, the nature of potential will remain same. So they are a spherically symmetric potential. So what you can assume there is some source of field or potential, and this is your, in general, we can say that in a spherical region, there is influence of this potential. Or in general, what you will assume? You will assume that potential will be just decreasing at plus infinity and minus infinity. What is meaning of that? Meaning of that, your particle will be free into this region at very high value of r, and this is also free into this region, and only influence is in this particular region. So we can just assume this is your region of influence of this particular potential. Okay. So we have a axis. Let's say this axis is incident axis. So my particle is coming from here. It will interact with this potential and it will scattered. So this is the whole idea. So let's try to see what we are going to do. So this is my axis. Okay, so this is my axis. So, and suppose at the infinity, my particle is free. So it has some energy. Let's say its energy is E. And the distance from the reference point, and this is perpendicular distance from the reference point, is B, where the particle is just going to approach to this particular potential. So suppose here is my potential, let's say VR. Okay. So, and this is your distance, the perpendicular distance when your particle is at the infinity. That means when your particle is not in an influence of this particular potential, not in an influence of this particular field, then this distance is known as B, which is very famously known as impact parameter. Impact parameter. So what we are going to do? पहले आप समझने की कोशिश करो करना क्या है. What we are going to do? We will take a very small cross section here. Let's say that cross section is dB, and we will send the particle from, and you can assume this cross section is something like this. Okay, and you have this cross section, and you are throwing the particle from here. You are throwing the particle, and the intensity of particle is I. So what is intensity? Intensity is number of particle per unit, number of particle per unit time per unit area. So intensity is number of particle per unit time per unit area. So here is the intensity of a particle. And now when particle will come here, it will come here and it will interact here. And what will happen? it will come here something like this, and it has some trajectory, and it will just go like this. So this is your in general trajectory of a particle. And here is your asymptote of this particular trajectory. What is the meaning of asymptote? This is tangent at the infinity. This is tangent at the infinity. And this distance is what known as minimum distance, R minimum. And you can assume this is your incident line. I am not confusing you with the z-axis. This is just an incident line. You can just assume here. So this is your R minimum. And the angle at which particle is going to deflect is the scattering angle, and I am denoted it by the angle theta. And this is capital theta. So please make it sure that you cannot confuse into the basically notation part. So capital theta is the scattering angle. So at which the particle is going to scattered. So this is your theta. This is known as scattering angle. Now look at here, and we are doing the classical scattering thing. So we are just going for the classical scattering. So when we are going for classical scattering, that means, what is the meaning of that? When I am throwing the particle from here, it will come here. Suppose this is your particle. Suppose assume this is your particle. It will come here and it will just go like this. If I am going to change the value of B, suppose I am changing the value of B, then obviously the scattering angle is going to change. Suppose I am just sending the particle from here, then obviously this will go back, something like this. So you know that this B is basically, this B have to be function of scattering angle theta. This is the whole idea. You have to understand that this B must be the function of theta. Now look at here. The particle is free here. The particle is free here. Don't worry. So when you are going to throw the particle from this region, it will exactly follow this path. When you will throw the particle from here, it will exactly follow this path. Don't worry. It will exactly follow this path. Why? Because we are doing the classical mechanics. And this is spherically symmetric potential. So for me, this plus infinity and minus, this minus infinity and this plus infinity have not any difference. So we can just throw a particle from here, or we are throwing the particle here, it will follow the exact same trajectory. So when it is follow the exact same trajectory, I can claim this R minimum will be divide the whole trajectory into two symmetrical parts. This is your R minimum. So why I can claim that this angle is alpha, this angle is alpha. In the Goldstein, they have used the sign psi. So I am using alpha because when you are going for psi, you will be little bit confused. But this psi is also known as parapsis angle. That means this, and this is measured from the R minimum. This angle is measured from R minimum. Okay. So one more constraint is there. 2 alpha plus theta is equal to pi. And from here, alpha is nothing but pi by 2 minus theta by 2. So you have to always take care of this particular statement. And now look at what we are going to do. Hum karte kya hai? We will throw n number of particle from here with some area. We will throw n number of particle from here with some infinitesimal area. And what we will do, we will try to collect all the particle with different detectors. So here there are different detectors. So what will happen when you are going to change B? Suppose at this particular B, we have this detector will work, and we will just try to calculate the all cross section. We will try to calculate the cross section where all the particle will collected by this detector. So that means the number of particle which is coming from here must be collected by this particular detector at here. Are you getting my point? ये चीज समझ में आ रहा है आपको? Everyone is comfortable?
Yes, sir.
So look at what I am going to do. I will consider a ring here of radius b and width of db. So this will be db. And so particle is coming from all this particular width. So I am just talking about this particular thing. So suppose here is again, and I'm just talking about this particular particle. And so hence number of particles. So whatever particle is coming from here, it will be collected by some detector here at the angle theta. And here we can measure this all thing with a solid angle. Okay. We will measure this all thing with the solid angle. Why? Because at the same B, the particle can come here, it will go like this. The particle can come here, it will go like this. The particle can come here, it can go like this. Are you getting my point? So what will happen? You will collect the particle in all solid angle. So you have some cone and you are just attracting the particle into this particular cone. So now we know the number of particle is conserved here. So the number of particle coming from this particular ring is basically I is the intensity. So number of particle per unit time we are actually calculating. So I is the intensity and this will be 2 pi b db. This will be number of particle per unit time must be equal to intensity into the solid angle, and solid angle is nothing but sine theta d theta d phi, and we are talking about all complete solid angle. This will make something like this. So we have this all solid angle. So we will take 2 pi here, and here is one particular term which will change by changing the potential, and that will be d theta. So this is something like area. This is something like area, and we don't know what is this particular d theta. And this is very famously known as differential scattering cross section. That means those cross section where all particle is going to just collected or all particle is going to detected by that particular cross section is d theta. And d theta is function of a scattering angle. So we have to calculate this particular d theta. And this d theta will be the number of particle collected by the detector at the angle theta and at the angles theta, and so that it will make the solid angle sine theta d phi. So what will happen?
So that is not visible.
Sorry,
So the extreme right.
क्या बोल रहे हो?
Whatever you are writing at the extreme right now, that is not visible.
आवाज नहीं आ रही आपको, बताओ फिर से.
सर एक्सट्रीम राइट बोर्ड पे दिख नहीं रहा सर.
अच्छा, एक्सट्रीम राइट पे दिख नहीं रहा है. ओके. ओहो, सॉरी. अब क्लियर है क्या? अब इधर नहीं दिखेगा. जस्ट अ मिनट. अब क्लियर है क्या? ओके.
यस.
चलो ठीक. ओके, सॉरी. So this is nothing but the differential scattering cross section. Okay, that is area in which all the n particle per unit time is going to collected by the solid angle at the angle theta. That solid angle is by sine theta d phi, and d phi is 2 pi. So what you have 2 pi I d theta sine theta d theta. So this is your differential scattering cross section. So from here, this I and I will cancel. 2 pi will cancel. So you have a very famous formula. This d theta is nothing but b upon sine theta, and this theta is all your scattering angle. B upon sine theta db upon d theta, and this will be mod value, and this is very famously known as differential scattering cross section. Now, so this is your scattering cross. And now what is your R minimum? This R minimum, if you will go into the central force problem, then you know that your motion is confined into a plane when your potential is central potential or spherically symmetric potential. Then this R minimum is exactly identified as turning point. What is this R minimum? This R minimum is exactly identified as turning point. So what will happen at turning point? याद है आपको? What will happen at turning point?
Kinetic energy zero. Radial velocity zero.
Sorry, turning point पर क्या होगा? At R is equal to R minimum. At R is equal to R minimum, what will happen? R dot is equal to 0. याद है ना? If it is turning point, then R dot value की वैल्यू क्या हो जाएगी? 0 हो जाएगी. याद है कैपलर्स लॉ और बाकी सारा जो किया था? Remember this thing? है ना? And this is a unbounded trajectory. कैपलर्स लॉ में आपने बाउंडेड ट्रेजेक्टरी के बारे में बात किया था. दिस इज व्हाट अनबाउंडेड ट्रेजेक्टरी. ओके, सो आपका पूरा आइडिया क्या है? पूरा आइडिया आपका ये है कि आप बी को थीटा के टर्म में निकालो, बाय हुक एंड क्रुक जैसे भी निकालो. ओके, इन जनरल ज्योमेट्री काम आएगा, इन जनरल आपकी बेसिक फिजिक्स काम आएगी. सो यू विल कैलकुलेट बी एज अ फंक्शन ऑफ थीटा, and after then once you will calculate b as a function of theta, you can easily calculate the d theta, the differential scattering cross section, and finally you will calculate the total scattering cross section, and this total scattering cross section is basically d theta sin theta d phi. This is your total scattering cross section. Sometime what will happen? Sometime your differential scattering cross section may be इंडिपेंडेंट ऑफ थीटा, तो उसको उसमें आप जीरो नहीं कर दोगे. आर यू गेटिंग माई पॉइंट? एक हम ऐसा प्रॉब्लम करेंगे, हो सकता है आपके एग्जाम में भी आ जाए इस बार, कि डिफरेंशियल स्कैटरिंग क्रॉस सेक्शन इज नॉट अ फंक्शन ऑफ थीटा, और सॉरी बी इज नॉट अ फंक्शन ऑफ थीटा. मे भी ऐसा केस हो सकता है दैट दिस बी मे नॉट बी फंक्शन ऑफ थीटा. देन व्हाट यू कैन डू, you can have this total scattering cross section is equal to b by sin theta db by d theta sin theta d theta. This thing is cancel and here 2 pi is there, so you have pi b square. Then your sigma is nothing but what? Pi b square. Okay, so you sometime आप डायरेक्ट ये फॉर्मूला भी यूज कर सकते हो टोटल स्कैटरिंग, बट दैट विल डिपेंड ऑन सिचुएशन, कहां पर किस तरह की बात हो रही है. अब आपके एग्जाम में क्या पूछा जाएगा? आपके एग्जाम में या तो डिफरेंशियल स्कैटरिंग क्रॉस सेक्शन पूछा जाएगा या तो टोटल स्कैटरिंग क्रॉस सेक्शन पूछा जाएगा. एंड दिस इज द इफेक्टिव एरिया. Differential scattering cross section and total scattering cross section is the effective area where particle is going to scattered by the potential. Okay, so you have to just remember all this thing. So let's try to hit different type of problems. यहां तक कुछ पूछना है पूछ लीजिए, otherwise I have to clean up my board. कोई नोटेशन नहीं समझ में आ रहा है? कुछ नहीं समझ में आ रहा है? जस्ट आस्क डायरेक्टली, है ना? क्योंकि इसी पर सारा है, क्वांटम मैकेनिक्स भी इसी पर डिपेंडेंट होगा. वहां पे डी थीटा ही इंपॉर्टेंट होगा, लेकिन वहां डी थीटा का कैलकुलेट करने का तरीका अलग होगा. ओके,
सर टोटल क्रॉस सेक्शन का फॉर्मूला में sin थीटा d phi है.
डी फाई साइन थीटा डी थीटा डी फाई टोटल सॉलिड एंगल के लिए करेंगे ना.
यस, d थीटा d phi.
डी थीटा डी फाई, इसको तुम बाहर ले लो तो डी फाई आ जाएगा. ठीक है, या फिर से लिख दूं, दिस सिग्मा इज इक्वल टू डी थीटा. एक्चुअली ये एक बोर्ड पर पढ़ाने वाली चीज ही नहीं है. साइन थीटा डी थीटा डी फाई, यहां पर डी थीटा डी फाई. इट इज वेरी टफ कि इस तरह के टॉपिक को एक बोर्ड पर पूरा एक्सप्लेन करना और कैलकुलेट करना. एनीवे, सो चले आगे. यहां तक क्लियर है आपका? चलो
sir.
अब प्रॉब्लम करते हैं और बहुत ही मजेदार मजेदार प्रॉब्लम करेंगे, डोंट वरी। ठीक है, बट पेशेंस लगा करके बैठे रहना, ये मत सोचना कि लास्ट समय में चल रहा है तो हमसे एग्जाम में नहीं होगा। मैं जो करवा रहा हूँ वही एग्जाम में आएगा, डोंट वरी। ठीक है, और आपसे होगा। क्लियर है? इसी कारण मैं स्कैटरिंग हमेशा एग्जाम के जस्ट पहले करवाता हूँ, ताकि बच्चों को रिवाइज वगैरह ज्यादा करने की जरूरत ना पड़े। ओके, चलो। So let's go for hard sphere. Okay, classical hard sphere. Okay, what is meaning of classical hard sphere? You have a sphere and particle cannot penetrate this particular thing. So what will happen? So this is my, and it has radius r. Okay, it has radius r. So this is my line of incident, and suppose I am throwing this particle from b height. So this is b. Okay, and this particle is going to scatter. ऐसा ही होगा ना? You assume that you have a football and you are throwing the marble ball. You are throwing a lot of marble ball on this particular football at this particular B. Obviously, B को ऊपर बढ़ाते जाओगे, ये चीजें चेंज होती जाएगी, है ना? So this is your hard sphere. That means this is infinite potential you have. Okay. So this distance is r, and this is your asymptote. So this angle is what? Theta. Okay. So this angle is also theta. And what will happen to this angle? ये एंगल और ये एंगल क्या होगा? सेम होगा ना? यस, अभी तुरंत बात किया था. सो सपोज दिस एंगल इज
Yes,
अल्फा, दिस एंगल इज अल्फा, दिस एंगल इज थीटा. सो व्हाट इज अल्फा? अल्फा इज पाई बाई 2 minus theta by 2. I am deliberately taking this scattering angle with the bigger theta. बड़े थीटा से इसको कर रहा है. ठीक है. नाउ व्हाट इज आइडिया? आपको क्या करना है? बी को किसके फॉर्म में लिखना है?
theta.
थीटा के फॉर्म में. सो यू कैन यूज ज्योमेट्री. This b will be exactly here. So you can write b by r is equal to sine alpha. ठीक लिखा हूं? So what is your b? b is equal to r sine pi by 2 minus theta by 2. So that value is equal to r cos theta by 2. So this is your b. Okay. So once you have, and now you can see this b is function of the scattering angle. आप थीटा को चेंज, बी को चेंज करते जाओगे, थीटा की वैल्यू चेंज होती जाएगी. Now we have to calculate differential scattering cross section. What will you differential scattering cross section? B upon sine theta dB upon d theta, and you have to always take a mod value because it is nothing but the area. It has dimension of area. It is some sort of area also. Actually, you are just going to calculate the how much area it is taken by the particle. Sorry, how much area it will taken by the detector such that n number of particle is going to collected by this. Add the angle theta plus d theta. So why it is known as differential scattering. Okay, differential theta to theta plus d theta. Small d theta के लिए कितने एरिया आपको जरूरत है कि जो भी पार्टिकल आप इधर से भेज रहे हो वो उसके अंदर एब्जॉर्ब हो जाए. So this is your differential scattering. Now, so why it should be always positive. So don't trap into mathematical differentiation कि नेगेटिव आ जाएगा तो डिफरेंशियल का स्कैटरिंग क्रॉस सेक्शन नेगेटिव हो जाएगा. नो. फॉर एग्जांपल यहां पर आप देख सकते हो बी की वैल्यू क्या लिखें? r cos theta by 2 by sine theta, and dB upon d theta is minus r cos theta, but we will neglect minus sign. So that will be minus r sine theta by 2 into 1 by 2. And you can write it this thing, इसको आप लिख सकते हो 2 sine theta by 2 and cos theta by 2. So this will be r cos theta by 2, r sine theta by 2, and you will have 2 into 2 times sine theta by 2 into cos theta by 2. So this thing will cancel out, and you have this is differential scattering cross section is basically r square by 4. So this is dimension of area, isn't it? This is dimension of area. Now you can calculate the total scattering cross section. So what is your total scattering cross section? The total scattering cross section is d theta. You have to just go for all solid angle, sine theta, d theta, and you can just go for 2 pi, that is 0 to pi, and you will get basically pi r square, isn't it? होगा ना? Just take it. So this hard sphere, classical hard sphere में effectively कितनी एरिया से पार्टिकल स्कैटर्ड करेगा? टोटल जो एरिया होगा, हर एक डी थीटा को आप कैलकुलेट करो, ऐड ऑन कर रहे हो, सो इफेक्टिवली जो एरिया होगा वो एक सर्कल की एरिया के बराबर होगा जिसकी रेडियस r है, दैट इज योर पाई r स्क्वायर. सो यू हैव एक्चुअली वन पर्टिकुलर सर्कुलर एरिया जिससे कि आपका टोटल स्कैटरिंग हो रहा है. अगर आप सारे डी थीटा को ऐड कर रहे हो, so it is not all about that it is scattered from the all this 4 pi r square, isn't it? This is very interesting. नहीं भाई, एक स्फेयर है और उससे आपका पार्टिकल स्कैटर्ड हो रहा है, लेकिन आपको मिल कितना रहा है? पाई आर स्क्वायर. क्लासिकल स्कैटरिंग की बात कर रहा हूं. when we will go for quantum mechanical scattering we will see some different situation. Okay, so this is your classical hard sphere. Clear है ये? Let's go for a very famous scattering problem, that is Rutherford scattering. है ना? This is very famous scattering. So let's try to go for Rutherford scattering. So whenever we are talking about Rutherford scattering, this VR is equal to K by R. Same as you have done into the Kepler's problem, but negative sign is not there. This is positive K by R. Okay, this is your Kepler's problem. Sorry, Kepler's potential actually, not Kepler's problem. So this is potential for Rutherford. So what we have? You have Coulombian potential. So what is Rutherford scattering? Alpha particle is coming to the gold nucleus and it has different angle, isn't it? After it is going to scatter at different angle with this particular nucleus, and alpha particle and this nucleus is just going to repel each other because both have same charge polarity. So let's try to go for this thing. So this is my source of potential, a source of nucleus. So this is my incident line. The particle is coming here and it is just going something like this. This value is basically R minimum. And this value is basically theta. Again, you know, this value is alpha, this value is alpha. Again, I am saying this alpha is written as by psi in Goldstein. Okay. Goldstein में इस अल्फा को psi ले रहा है, but I, in general, classical mechanics, I hate this psi thing, so I deliberately use alpha. Griffith ने alpha लिया है, so I have taken the Griffith notation. Okay, good. Now, just if you can remember the trajectory of this Kepler's problem, this is my polar angle, isn't it? Theta. And this is my R minimum. Remember? Hana? This is your R minimum.
Yes, sir.
So theta is measured from where? R minimum, isn't it?
Yes, sir.
है ना? और अगर ये सपोज करो अगर ये अनबाउंडेड ऑर्बिट है तो ऐसा ही तो होगा कुछ, है ना? सो दिस इज योर एंड दिस इज योर आर मिनिमम। इसको भी हटा देते हैं, सिर्फ एक ही तरफ का ही देखते हैं। सो दिस इज योर आर मिनिमम एंड दिस इज योर ऑल पॉसिबल आर, इजंट इट? क्लियर है ना? सो थीटा कहां से आप मेजर कर रहे हो बेसिकली? देख लो, आर मिनिमम से मेजर कर रहे हो। आर यू गेटिंग माई पॉइंट?
Yes, sir.
है ना? तो थीटा इज मेजर्ड फ्रॉम आर मिनिमम। सो दिस इज योर, so at some particular point I can say this value is theta and this coordinate is r and theta, and I am talking about a polar coordinate system whatever we have learned into central force potential. So मैं उस theory की बात कर रहा हूं. So this is my theta, and for this particular potential is equal to k by r. You remember the equation of trajectory is L by R is equal to 1 plus E cos theta. And this theta is not this theta, please. This is small theta. Okay. This theta is not this theta. This theta is this theta. Are you getting my point? Are you
Yes.
getting my point?
Yes, sir.
ये थीटा आपका स्कैटरिंग एंगल है जो कि स्फेरिकल पोलर में आप चीजों को देख रहे हो, और वो जेड एक्सिस से बना रहा है। लेकिन जब आप इसकी ट्रेजेक्ट्री की बात करते हो तो ट्रेजेक्ट्री के लिए हम लोगों ने क्या सॉल्व किया था? 2 डायमेंशनल प्लेन पर सारा चीज सॉल्व किया था। रिमेंबर दिस थिंग सेंट्रल फोर्स प्रॉब्लम में, एंड दैट इज द इक्वेशन ऑफ व्हाट? कोनिक सेक्शन। रिमेंबर यू ऑल दिस थिंग, है ना? नाउ what will happen, and this is eccentricity, what will happen when r tends to infinity? थीटा की वैल्यू क्या हो जाएगी जरा बताओगे? When r tends to infinity, what will happen to this small theta? देखो तो क्या होगा, बताओ जल्दी बताओ, फिर से कर दूं?
90 degree.
अरे 90 कहां से? देखो, ये है तुम्हारा अल्फा, ये है तुम्हारा ट्रेजेक्ट्री, दिस इज योर आर मिनिमम। देखो कहां जा रहा है, इन्फिनिटी पर। बताओ तो, अभी भी नहीं बता पाओगे? अरे देखो तो किधर जा रहा है भाई, थीटा इज इक्वल टू अल्फा, नहीं? एट आर टेंस टू इंफिनिटी तो थीटा की वैल्यू कहां जाएगी, अल्फा नहीं हो जाएगी? फिर से देख लो।
Yes, sir. Yes, sir.
अरे देखो तो, इतना मजेदार है ये, समझ में नहीं आएगा। देखो, ये हो गया आर मिनिमम एंड दिस इज योर थीटा, ठीक है? नाउ अब आर को आप बड़ा करते जाओ, किसकी तरफ मूव कर रहे हो? अल्फा की तरफ नहीं मूव कर रहे हो क्या? कर रहे हो या नहीं?
Yes, sir.
What is alpha? Alpha is this asymptote is making angle with r minimum, isn't it? And what will happen when r tends to infinity? You were just
Yes,
lying
sir.
on the asymptote. Asymptote is the tangent at the infinity, isn't it?
Yes.
So theta is equal to alpha, and we all know r tends to infinity. So from here, the value of cos theta is equal to minus 1 upon e. हो जाएगा ये, और e is equal to something written as, cos alpha is equal to 1 by minus 1 upon e. And what is your cos alpha? अल्फा को क्या लिख दोगे? पाई बाई 2 माइनस स्कैटरिंग एंगल अब लेकर के आ गए, दैट विल बी minus 1 upon e. So this value is nothing but sin theta by 2 is equal to minus 1 upon e. So this is one particular thing. Now, लेकिन आपका चैलेंज क्या है बताओ? व्हाट इज योर चैलेंज? करना क्या है क्लासिकल स्कैटरिंग में?
B in terms of theta.
बी को थीटा के टर्म में लिखना है ना? तो अब कैसे लेकर आते हैं जरा वो समझने की कोशिश करो। वेरी इंटरेस्टिंग, वेरी इंटरेस्टिंग। मजा आ जाता है जब इस प्रॉब्लम को करो कॉन्सेप्चुअली। तो Now, okay, now look at here. At this particular point, I have energy E. Are you people happy? And this is your R minimum. Okay. At this particular point, my energy is E. Okay. And I can write from here, this E is equal to 1 upon sine theta by 2 with the negative sign. लिख सकते हैं ना? And this is nothing but minus cosec theta by 2. And what is your E square? E square is equal to cosec square theta by 2. Okay? और अगर आप चाहो तो इसे लिख सकते हो E square minus 1 is equal to cosec square theta by 2 minus 1. That is cot square theta by 2. यहां तक क्लियर हो ना? यस, लिख सकते हैं ऐसा?
Yes, sir.
ठीक लिखा हो ना? cosec स्क्वायर माइनस थीटा माइनस 1 इक्वल टू cot स्क्वायर. ठीक है कि नहीं? यस. ओके. नाउ look at here. What is your E? E is equal to root under 1 plus 2E J square upon MK square. Remember? याद है? For the potential which is proportional to 1 by R. यही है ना?
Yes, sir.
Okay. So from here you can write E square minus 1 is equal to 2EJ square upon MK square. Clear है ये? E तो आपको एनर्जी दिया हुआ है. Now, what will be energy at this point? Is that any potential energy at this point? And this is your value of B. What is that any potential energy at this point?
No, sir.
No. So all energy is nothing but what? Kinetic energy. So this
Kinetic.
E is at this point is kinetic energy, and that value is half mv naught square. Everyone is comfortable? And what is your angular momentum at this particular point? This is your direction of V. What is angular momentum?
MPV.
Very good. That value is mv naught. So that is mv naught B is your angular momentum. And from here, you can write this J is equal to mb, and you can just take it 2E upon m root under. So this value is equal to root under 2em into B. This is your angular momentum if energy is given, and this energy is nothing but the kinetic energy. ये जो energy है, ये energy कुछ नहीं क्या है, kinetic energy है. Are you people happy? So I can put value of J here, and when we will put value of J here, you will see the B will automatically come into picture. है ना? So this is your E square minus 1 is 2E, and what is your J square? Is 2E upon M B square upon M K square. This M and M will cancel out, and you have E square minus 1 is 4 E square B square upon K square. Okay, so this is E square minus 1, and from here you can write this particular thing. We can write E square minus 1 is equal to 4 E square B square upon K square is equal to cot square theta by 2. And from there, you can calculate the value of B, and the value of B is equal to K upon 2E cot theta by 2. Generally लोग इसे रट करके रखते हैं, और हम लोगों ने इसे derive कर लिया. Isn't it? B is nothing but K upon 2E cot theta by 2. And what is your K? K is nothing. Z1 into E and Z2 into E, दोनों का multiply है ना? E square by 4 pi epsilon naught. that thing can be k. So I am just using k here. So here and this theta is nothing but the scattering angle. So don't worry. This is your scattering angle. So आप confuse मत करना, है ना? So my purpose have been covered here. हमारा purpose यहाँ पर पूरा हो जा रहा है. यही तो challenge था ना? What is your challenge? You have to write b as a function of theta. This is your real challenge, and we have just do this thing very beautifully. Now, once you have got this particular thing, you can get differential scattering cross section. And I am writing in capital theta, that will be b upon sine theta, and this db upon d theta. You can just calculate it. I will just give you the final version of answer. Okay. So this value is equal to, जस्ट आप एक बार कैलकुलेट कर लेना, बट यहां तक क्लियर है ना? मिटाऊं क्या? देख लो. चलो. So you will get differential scattering cross section as d theta as 1 upon 4 k square upon e square and 1 upon sine to the power 4 theta by 2. So this is very interesting. और इसके ऊपर खूब क्वेश्चन आते हैं आपके एग्जाम में. If your sin theta is very small, अगर आपका sin theta बहुत स्मॉल है तो d theta को क्या लिख सकते हो? 1 by 4 k square e square theta by 2 to the power 4, है ना? So that will be, and this theta is a scattering angle. So d theta is proportional to e square. It is proportional to theta to the power 4 for a small angle of theta. Otherwise, you have to just calculate this value of sin theta. So this is one of the wonderful problem for classical scattering. Okay. So let's go for one more problem. अभी हमारे पास समय है ना? Yes, 10-minute time है हमारे पास, isn't it? चलो, let's try to go for one more problem. तो ताकि नेक्स्ट क्लास में हम क्वांटम मैकेनिकल स्कैटरिंग की बात कर सके. हटा दो इसे. यस. आप एक बार कैलकुलेट कर लेना ये आ रहा है या नहीं. चलिए. So let's go for our next problem. So what is my potential? My potential is, let's say V is equal to some VR, where capital R is the R minimum और मिनिमम अप्रोच. इसको सम टाइम आप क्या कहते हो? मिनिमम अप्रोच. कि मींस उससे ज्यादा अप्रोच पार्टिकल नहीं कर सकता है किसी को. फॉर एग्जाम्पल, अगर आपके पास डिस्क है या फिर स्फेयर है, तो स्फेयर की रेडियस क्या होगी? वो मिनिमम अप्रोच होगा. आप उसके अंदर नहीं जा सकते हो. सो सिमिलरली there are, for the potential, we can define some minimum approach. So VR minimum is minimum approach. Suppose E is the energy given to particle. So this is your constant energy given to particle. What you have to do? You have to calculate the total scattering cross section in term of R and V. Okay, and VR is, it may be some type of potential, kr square, कुछ भी हो सकता है. So obviously, what is going to happen? This is my whole story. This angle is theta. This angle is alpha. This angle is alpha. Okay. And this is my B. So now, what is your एंगुलर मोमेंटम, सपोज दिस इज योर वी नॉट, वी नॉट से आप इसको इंसिडेंट फेंक रहे हो एट इन्फिनाइट, सो इन्फिनिटी पर ये क्या होगा, दैट विल बी फ्री पार्टिकल. ओके, this is assumption behind all this classical scattering. We assume when we are throwing the particle, it will behave like a free particle. So what is your J? M V naught B, and which will be written as 2m E into B. अभी तुरंत किया था इसे. This is your value of J. Okay. Now this J will conserve. ये J क्या होगा? Always conserve रहेगा. Isn't it? This J will conserve. Now we will just go for total energy of a conservation of total energy at this point and at R is equal to R minimum. So this is your R. So इस point पर हम conservation of energy ले सकते हैं. What is at energy this point E, and this energy will conserve at this point. So किसी भी arbitrary point पर energy लिखोगे R dot square plus J square upon 2m R square plus VR, यही तो होगा. This is your centrifugal term और rotational kinetic energy पता है हमें. What will happen at R is equal to R minimum? That is at R is equal to R पर क्या होगा जरा बताइए. What is physics behind that?
R dot equal to 0.
R dot is equal to 0. So you have R dot is equal to 0. So what is your E? Your E is equal to basically J square upon 2m R square plus VR. And we can easily calculate the value of J from here. So we have E is equal to J square, we can write 2m E B square upon 2m R square plus VR. So we can easily get value of B here. So what is value of B square? The value of B square is equal to E minus VR by VR. This is your value of B, isn't it? B by R square. This is value of B by R square. And from there, we can get value of B is equal to R. And this is root under E minus VR by E. Now here you can see this B is not a function of theta. This B is not a function of theta. So what will be your total scattering cross section?
Sir, by VR.
Pi B square, है ना? So sigma
Sir,
is equal to by sorry by E होगा ना, by not BR by E. Sorry. ये इधर से इसको घटाएंगे, इसको डिवाइड करेंगे by E. Sorry, है ना? So this value is equal to what? What is sigma? Pi B square. So that is pi and B square को ले जाओगे. So this is pi R square E minus VR upon E. So this is your sigma. खत्म. आपके एग्जाम में आ चुका है ये. I think 2 साल पहले जेस्ट के एग्जाम में आया था. ओके, B निकालने के लिए आया हुआ था, है ना? They have just asked what is the value of B such that it will approach to the minimum approach R, है ना? B की क्या वैल्यू होगी कि मिनिमम अप्रोच R होगा, या फिर वाइस वर्सा शायद R की फॉर R मिनिमम अप्रोच व्हाट शुड बी B. इस तरह से कुछ क्वेश्चन था. सो यू कैन इजीली यूज दिस थिंग. सो नाउ आप देख रहे हो क्या यूज कर रहे हैं. कंजर्वेशन ऑफ मोमेंटम, कंजर्वेशन ऑफ एनर्जी and the all property of central force problem. That's it. So this is application of central force problem for a unbounded trajectory. So this is how we can approach for the classical scattering. But हमारा जो real target है, that target is all about quantum mechanical scattering. So tomorrow we will just go for a Born approximation, जिसके through मेनली प्रॉब्लम आते हैं आपके एग्जाम में. एंड देन यू विल सी हाउ ब्यूटीफुल इज दिस थ्योरी, और हम लोग समझने की कोशिश करेंगे कंप्लीट थ्योरी ऑफ स्कैटरिंग. बट पहले एग्जाम वाली चीज को कर ले. ठीक है, थैंक यू. कुछ पूछना है? चलिए, थैंक यू.